Okay, for this video, we're going to be doing lesson 4-3 part 2, where we build off of the prime factorization that we already learned, and now we're looking at finding the greatest common factor between two different numbers. So you should already have parts of these notes filled in, and so we're just going to be adding the parts that we haven't done yet. So the greatest common factor, or the GCF, is the greatest of all common factors of two or more. Okay, so we're going to essentially make factor trees and then figure out what factors the numbers share, and from that we'll be able to figure out the greatest common factor. So all of the notes that we're going to fill in are going to be on the back. So go ahead and flip your page over to look like this. So we are going to find the greatest common factor between 24 and 30. So to start, we're going to make trees. 24, we can break apart, always starting with 2, right? So we could do 2 and 12. 12 we can break apart to be 2 and 6. 6 we can break apart to be 2 and 3. Then we're also going to make a tree for 30. 30 we can break apart with the 2 to be 2 and 15. 15 we can break apart to be 3 and 5. Okay, so this is where things get a little different. Yesterday, or the last class, when you were doing prime factorization, you wrote PF equals and you made a list of the factors. This time, you're going to actually use the number, the top number, as the beginning of that statement. So you're going to say like 24 equals. And then you're going to list your prime factors. So you're going to have 2 times 2 times 2 times 3. Underneath it directly, you're going to write 30. And you're going to have 2 times 3 times 5. Then we're going to look at this and we're going to figure out what do they share. So they share a set of 2's and they share a set of 3's. From that, we can figure out the GCF. So we say GCF equals 2 times 3. So since we circled a pair of 2's, we bring down a singular 2. We circled a pair of 3's, so we bring down a singular 3. So like the stuff in the circle, you only write it one time. So it's not two 2's, it's 1. It's not 2 3's, it's just 1. Okay, so you write the number that they shared. That can get a little complicated. So that means that our GCF, if we multiply those together, is going to be 6. Okay, we're going to not write it the way they did. But we have 2 times 3, and we have 6. So the greatest common factor between 24 and 30 is 6. Okay, so it's very similar to what you were doing when you were doing prime factorization. There's just that step afterwards where you're going to figure out what the greatest number that they share is by figuring out what small numbers they share and then multiplying it back together. So let's look at this next one. It says 36ab squared and 81b. So let's start with just the numbers. We need to make trees. So we're going to have 36 that we break apart. And 36 is going to break apart to be 2 and 18. 2 and 9, 3 and 3. 81 is going to break apart to be 3 and 27, 3 and 9, and then 3 and 3. When we're writing them in our prime factor form, we need to remember to bring the letters down with us. So like this first one you would write as 36ab squared equals, and you would write your prime factors from the tree but then you also write the letters as well. So you would have 2 times 2 times 3 times 3 times A times B times B, because we had AB squared at the end of that. For 81B, okay, I'm getting these from here, right? 36AB squared and 81B. We're going to have 3 times 3 times 3 times 3 times B. And then we go back, and again, we circle the things that they share. So they share a B, they share a 3, and they share a 3. So when we're bringing those down, we only write one thing per bubble. So GCF equals 3 from that first one. Here, I'll write it underneath it. 3 times B. So since they shared this set of 3's, I wrote 1. Shared this set of 3's, I wrote another. Shared a set of B's, there's a singular B. When I multiply that together, 3 times B, I get that GCF equals 9B. They had this as like 3 to the second times B, so 9B. 9B. We're not going to do it that way. We're going to do it this way, where you have the longer lists so you can circle exactly what they share. So that's all the new stuff. So now we're going to go down and do some quick checks. I'm going to do A with you, and then you'll do B on your own. So first things first, we got to make a tree. We have 8. Breaks apart to be 2 and 4. 4 breaks apart to be 2 and 2. We have 20. Breaks apart to be 2 and 10. 10 breaks apart to be 2 and 5. Remembering to always start with 2's. Okay, then we're going to say 8 equals 2 times 2 times 2. And 20 equals 2 times 2 times 5. And we can circle, what do they share? They share this set of 2's. They share this set of 2's. So the GCF is going to equal 2 times 2. This set of 2, I brought 1 down. This set of 2, I brought 1 down. GCF equals 4. So the greatest common factor between 8 and 20 is 4. All right, so you're just going to do B, and then you're going to stop. So pause the video while everybody works on B. All right, hopefully what you have for B, make a tree for 12. You have 2 and 6. 6 is 2 and 3. For 87, you should have 3 and 29. 29 is a prime number, so that's where you stop. So you should have 12 equals 2 times 2 times 3. And 87 equals 3 times 29. What do they share? All they share is a 3. So you should just have GCF equals 3. They share that pair of 3's, so 1 3 comes down. Nothing else comes down, so that's the answer. All right, let's do C together. So for the trees, we just use the numbers, right? So we're going to have 12, which breaks apart to be 2 and 6. 6 breaks apart to be 2 and 3. Then we're going to do a tree for 8, 2 and 4, 2 and 2. Then we have to remember the letters when we're writing our prime factor form down here. So we're going to say 12r to the third equals 2 times 2 times 3 times r times r times r, because it was r to the third. Then we have 8r equals 2 times 2 times 2 times r, okay? You go back and circle what they share. They share that set of 2, that set of 2, and a set of r. So when we write our greatest common factor, we're going to say GCF equals 2 times 2 times r. Because again, they share this set of 2, I brought 1 down. They share this set of 2, I brought 1 down. They share a set of r, I brought 1 down. Gonna multiply that straight across, and I'm gonna end up with 4r as the greatest common factor between 12r to the third and 8r. All right, so go ahead and pause the video and everybody do D on their own. And then we'll come back together and check it. All right, so hopefully what you did for D, we have 15 for our first tree, so you should have 3 and 5. And then those are both prime, so we stop. Then for our second tree, we have 45, so you should have 3 and 15. And then 15 breaks to be 3 and 5. Remembering when we write them in prime factor form that we need to bring those letters back into it. So we have 15m to the second n, and we're going to write that as 3 times 5 times m times n. Okay, because we had that m to the second n at the end of it. For 45m, you're going to take the ends of your trees, so you have 3 times 5 times m, because of that m in this statement. What do they share? They share a 3, they share a 5, and they share an m. So for your greatest common factor, you should have GCF equals 3 times 5 times m, because again, they share a set of 3s, I bring down 1 3. They share a set of 5s, I bring down 1 5. They share a set of m's, I bring down 1 m. When I multiply those together, I should get 15m as my greatest common factor between 15m to the second n and 45m. All right, that wraps up lesson 4-3, part 2, where we're talking about greatest common factor.